So thanks so much for having me again at JNation. I was really excited to be invited back to speak at JNation. Roberto, who this conference wouldn't be possible without him, invited me to speak at the first JNation event. And I'm really, really excited that we're back in person. We can have events like this again, and I get to reopen JNation post-COVID. So thank you all for coming. And my day job is I run developer relations at JFrog, but I think one of the big things which is trending in the industry and we all need to understand as developers is open source supply chain security. Now, like any complicated topic, I think it's best explained with sci-fi references. So we're gonna hopefully explain everything you need to know about open source supply chain security purely with sci-fi references. So let's see how this goes. So I think first of all, you know that open source software is just used everywhere. Your typical enterprise application has 80 to 90% of the code base is dependencies on open source projects. So the majority of the code you're running in production isn't code you write, it's code which you depend upon. And I think this is kind of the crux of what's happening is now it's both exciting and scary time to be a software developer because if your parents or family members watch the news, they've probably heard about different supply chain attacks. So they might actually know what you do for a change. I'm used to just being a developer who codes in a closet and nobody knows what I do. So having things like, this is a historic example. So the Equifax breach, I think this highlighted the risk of supply chain security in the context of zero-day vulnerabilities. But what's happening is, as we move along, the range and the type of attack which is happening is becoming more invasive. It is more targeted at companies and attacks at specific organizations. And they're increasingly using open source supply chain. SolarWinds was a good example of this, where they attacked the CI/CD pipeline, injected malicious code right before they did the code signing. So it was actually an implementation where they injected malicious code that would open a backdoor when the SolarWinds software was installed on site, and that allowed them to exfiltrate code. It wasn't discovered until they found the actual data being exfiltrated from different government organizations. And this prompted the White House security order, which, among other things, mandated and recommended SBOMs for government organizations. And we're increasingly see this trickling down to consumer organizations as well, where it's becoming essential that you have a software bill of materials, that you have traceability of all your open source artifacts. And just a few weeks ago, on the anniversary of the White House security order, we had an open source summit at Washington, D.C., which I was part of. I'm also on the governing board for the OpenSSF Foundation. And we had government officials saying, OK, a year later, we mandated SBOMs, we got the whole industry behind improving open source security, and now we have lots and lots and lots of SBOMs that we have no idea what to do with. So security is better, but it's still a huge issue. And I think this is one which affected all of us and was recently highlighted, was the Log4Shell vulnerability, where if anybody here use Log4j, just raise of hands. OK, a few people in the audience. And this highlighted how vulnerable the industry is with a zero-day exploit, which had been in the code for a while and was exposed recently and forced us all to quickly patch if we were using the higher-level Log4j libraries. Of course, if you're using the Log4j core, it wasn't affected. But the basic attack mechanism here was that you could inject a JNDI URL, which would call back, and then this would pull back code, which would execute maliciously on the machine you were attacking. It's very easy for you to test for this, so you can poke and you can test different servers to see if they have this vulnerability, so it makes it easy to scan and look for affected services. And then this would give you arbitrary code execution on the target machine, which is the holy grail of supply chain security attacks. So I think that this is something we all dealt with earlier this year to patch. Spring Shell followed shortly, which was a similar vulnerability. And this highlights how important it is for us to secure the open source supply chain upstream. So I think this represents the tip of the iceberg for potential open source vulnerabilities. There's a whole lot more of them out there. There's a whole lot more work we need to do to secure open source software, and also to make sure that the enterprise software we build and depends upon it is secure. So how many of these different repositories do folks use? Anyone use NPM in the audience? OK. I have some security exploits for you. Anybody use PyPy? OK, I have some for you too. And how about Ruby gems? OK, not today, but we found security exploits in all of these central repositories. And I think that one of the challenges is that as developers, this is the source where you easily get package management. You pull down dependencies. You pull down libraries from these sources. And the attackers know this, and they're finding different ways which they can exploit this as a vehicle for injecting malicious code into our enterprise software. Now, I think a high-level way of looking at this is every time which you are doing a pip install, a go get, or an MVM fetch, then you're basically doing the equivalent of taking a USB drive off of the pavement and plugging it into your production servers. So if you can imagine, this is something we've all been taught from a security standpoint. Don't plug random USB drives into your computer. You'll get a virus. So this is the equivalent for enterprise systems and for servers. And this highlights how important it is that we all work together to secure these upstream repositories which we depend upon. OK, so like any good presentation, we're going to use some sci-fi references. So anybody know this film? Just shout it out. OK, good. So we all know the Matrix. Now we have all the main characters for the Matrix here, right? But we're missing somebody really important. I think this person is the star of the Matrix show, and of course it's Agent Smith. Oh, Roberto. Oh, OK. So if you watch the movies. OK. How's my pronunciation? OK. I got it. OK. So if you watch the latest movie, this was a travesty in my opinion. This isn't Agent Smith. So they recast Agent Smith with a different actor. They gave him, I don't know, a weird role in the movie. He wasn't even the main bad guy. But these are the real agents, right? The classic agents. And I think the agents of the Matrix are a really good way of describing the next attack, which I'm going to talk about, which is a dependency injection attack. So like in the Matrix, the agents they take over different people's bodies, and they'd consume them, and they'd use those as a proxy to then try to get the main characters. And this is exactly what happens with the dependency confusion attack, which was done by Alex Spierson, and it's a clever attack which hijacks your corporate dependencies by taking over the namespace. So this is the exfiltration technique. So once they get inside your servers, they're using a custom DNS server to then bounce traffic back, and this is how they actually get some of the data out of your network without it being spotted, because it's all masked as DNS traffic. The actual attack was based upon package binding, so they would use this to figure out what dependencies you had internally to get some of your internal namespaces. So like for this example, these are some internal libraries used by Yelp. And the way the attack works is when you, inside of your internal network, go to fetch a dependency, let's say the latest version of your awesome corporate library, normally what you would expect is that it's going to go to your internal server. But they publish a newer version on the central repository with the same name, the same group ID. And then you fetch the one from the external repository instead, because your vulnerable package manager doesn't know about this. And then bad stuff happens. As we know, don't put big red buttons in front of kitties. Now, one way to stop this sort of attack, and we've fixed this specifically with our package management system, Artifactory, is if your package manager is smart enough to know that it's an internal dependency, that it shouldn't go out to an external repository to fetch it, then you can block this sort of attack from happening and make sure that you only go to open source repos for open source libraries, and you only go to your local dependencies for local libraries. You would think that this has been patched and that most companies now aren't vulnerable for dependency injection attacks. But just a few weeks ago, we found an example in NPM where they had a dependency injection attack with some new modules which were checked in. They were specifically targeting an organization. It was all internal namespaces from a particular company. We contacted NPM, had the libraries pulled down, and then published our findings on our security blog. The group who took credit for it was a security research firm. So they said they were just testing for vulnerabilities and essentially making sure that they didn't have these sort of attacks for their clients. But this is a very prevalent attack and also a very profitable one. Alex Pearson did multiple different bug bounties on this and collected 130,000 from folks like Apple, Facebook, and a whole bunch of other Bay Area companies, all off this single dependency injection attack. He basically proved this across a dozen different organizations simultaneously and scooped up all the bug bounties for it. So maybe a new career, if you have a good security exploit, do some bug bounties, and then you don't have to code for a living. OK, so the next example I want to do is I think since we're doing the science fiction theme, we definitely need to have a Star Wars reference, and I think the best example of this would be the Millennium Falcon, which what's wrong? OK, so anybody been to the DevNexus conference in Atlanta? OK, a few folks. One of the speakers last night at the speaker dinner was wearing one of the DevNexus shirts, and Vincent Myers and I, who ran the conference, we did a mix-up of the USS Enterprise and the Millennium Falcon. And on the ship, we actually had like the head of the USS Enterprise, or no, it was the Enterprise. And then it had the little thing at the edge there for the Millennium Falcon poking out of the dish, which I think is a fun mashup. But the Millennium Falcon, as an example, as you know, is a smuggler's ship. And one of the ways which you get vulnerable dependencies into different organizations is by smuggling things which shouldn't exist in those repositories. Why would you trust a guy like this, right? So I think actually we have a better person in the community who represents this. Does anyone know Han Solo on Twitter? OK, so a little more trustworthy, right? But from a dependency standpoint, PyPy as an example is a great place to smuggle and to put things. And it's extremely easy for you to upload different packages into PyPy. So as you know, PyPy is the package manager for Python. You just do pip install to install new packages. It downloads and installs from PyPy. And it's very, very easy for you to upload new dependencies. So our research team scanned the whole PyPy repository. They were looking for different malicious vulnerabilities inside of it. And this is one of our researchers, Svetter. So he's actually one of the guys on our new Israeli research team. And he has this awesome PyPy module. You can actually check it out in PyPy. It's still there. It's called Svetter 0.8. And it does extremely valuable functionality, which is it opens his website. So if you install it, it will pop open his website. So if Svedder, one of our security researchers, can stick a random module in which is going to open his website, the attackers can do this very easily too. And when we scanned the whole PyPy repository, we found 300,000 of the 300,000 packages there. We got 6,000 hits on potentially malicious libraries. We were looking for things which were doing evals with constant inputs, so that would be an example of an obfuscated code. Trying to read-write sensitive files, spawning command shell pipe to network socket, and evaluating arbitrary strings from the network as code. All these things are things which you wouldn't normally expect libraries to do. And specifically, we found a couple exploits which we could reverse engineer and figure out what they were doing. One was noblesse, optimizes your PC for Python. It actually steals your credit card. Another one was Pythagora, make the Pythagorean theorem easy, and it would run any Python code received as string from the network. And both of these packages obfuscated their code, and together they got about 30,000 downloads. So it was something else about the way which both PyPy, NPM, and a lot of the package managers work. This isn't true for Java package managers. When you first install them, they have install hooks which run, and so you don't even have to run or depend on the library. Simply by syncing the library down or having it synced by a dependency, it will run the install hook and immediately execute the malicious code on your machine. And the way in which they would get your credit card, for example, is while your browser is designed to be really safe against websites getting access to your credit cards, right? So it's nicely partitioned off from JavaScript code. You can't get direct access to the database. At the end of the day, it's really just a SQLite database. And it's not even password protected. So you can go in there, you can get the SQLite database, you can decrypt it just using user credentials. So you call crypt unprotect data. And any locally executing code can directly get access to all of your passwords, credit cards, and other information stored in your browser. So think twice before you save your credit cards and other stuff in your browser. And this is the actual code which would steal the credit card once it was deobfuscated. So you can see it's not a lot of code. It's easy to do. And again, this gives you an easy way to see how dangerous these sort of supply chain security attacks are. This is an example of doing things on the local machine. So it's common for these sort of systems to steal credit cards, steal Discord Nitro tokens, and often they'll exfiltrate the data through Discord as well because they want a protocol which wouldn't normally be flagged by software looking for firewall breaches. But increasingly, we're seeing folks use these sort of attacks to attack companies. So if you are targeting a specific company, getting access to developer machines, getting access to corporate resources allows you to hop internally and then execute attacks against corporate networks. OK, so I have another sci-fi example. So this is a fun game and a really classic one. So we have the old school war games, right? And if you remember the movie, it was all about basically computers executing AI and playing a game to do a war simulation. So in our war simulation, we have to pick some countries or some cities to bomb. So I need just shout out some example cities. Give me some cities in Russia that we should bomb. Just shout them out. Moscow. Any others? St. Petersburg. I heard St. Petersburg. I heard Moscow. OK, let's go. So let's do Moscow first. Moscow. What's wrong? OK, so this is Moscow in Idaho, right? OK, that was a bad example. I mean, we forgot to say what country. St. Petersburg, we got this. Uh-oh. Or is he okay? Okay, so this is a simple example. Obviously now we've blown up the US, so you guys are safe here, don't worry. But it's an example of leaving off the prefix, right? We left off the namespace, and therefore we chose the wrong package. Now, before we go on, we're making fun of Russia, but I think on a more sensitive note, I think we're all very concerned about the situation going on with Russia, Ukraine. We were chatting at our table last night at the speaker dinner about how we all want to help and are finding different ways which we can help out by helping on the border or contributing in different ways to relief aid. And one of the things which we did recently at JFrog, which I was proud of as an employee, is we sent a mission of different employees out to help on the border. So they landed in Poland. They went to the border, or in Czech Republic. They went to the border between them and Ukraine. And they brought different supplies and relief for folks there. Obviously T-shirts, because you need clothes as well for relief aid. Here are some of the workers. We tried, just for sensitivity, not to show pictures of refugees in the photos, so it's mostly pictures of employees for that reason. And of course, frogs. So I think that it was really great that we were able to do this sort of humanitarian work. And I think also something which is rare is the person on the very right of the photo there is the CEO of our company, Shlomi Ben-Haim. And he not only joined the missionary work, I don't know if our board of directors and investors were happy with us sending our CEO to a war zone. But he also worked on the front line, helped out, and he ended up getting COVID as well on his way back. So he was trapped in Israel for an extra week. So I think that shows that the sort of dedication and care which our leadership really has. Okay, so getting back to the technical part of the talk. So I was talking about leaving off namespaces and prefixes in the previous example. And this is exactly the sort of exploit which we found happening for libraries in NPM, where it was targeting developers using the Azure libraries. And for example, this is Azure Core, if you're coding against the Azure cloud. And if you happen to leave off Azure and just do core tracing, this is the package you would get back. And so they took all of the different namespaces for Azure. They put in fake packages so that if you accidentally left it off, you would pull down these packages instead. This is a classic typo squatting technique. And they even went so far as to use different users for each of the different NPM modules which they published to make it less obvious that this was a security exploit, and also to make it harder to find all of them at once. So there were 218 packages they checked in, which were like this: Azure, Azure Test, Azure Tools. The code would exfiltrate personal information from the developer machines once it was installed. And this, when we caught it, it seemed to be just them testing to see how many vulnerable instances there were. So this was basically testing out the typo squatting technique. And we were able to get NPM to obviously pull down the packages, and then we published the security info about this. But this is another example of organizations, malicious hacking organizations, finding different ways to use public repositories to gain access to developer machines and ultimately to corporate networks as a way of getting in. So all of this information on these exploits and more can be found at the JFrog research site, research.jfrog.com. We publish the security exploits. This is also where our research team, which does all the zero-day exploits and data input for X-Ray, our security scanning tool, also works. And it's a good resource just to find about open source dependencies and the vulnerabilities which are there. So as we talked about earlier, we can solve this all with S-bombs, right? Oops, I went too fast. So we have the salsa to help us. Okay, so salsa actually stands for supply chain levels for software artifacts. This is one of the OpenSSF projects where they mapped out the different potential dependencies for where you can get vulnerabilities, and they have different levels that you can certify yourself or look for projects which are certified to see how many of these different exploits which they handle. And from the start, you can get a lot of vulnerabilities coming in from source control systems, from compromised build servers, but then even dependencies and package management systems are also potential vulnerabilities. And if you want to secure the entire software supply chain, you have to secure this end-to-end. So one of the things which we're working on as an open source effort is building a project to secure the open source supply chain, which is automated, kind of like Iron Man, trustworthy. I'm not sure a Russian spy is a good example of being trustworthy, but Black Widow, and dependable like Captain America. And the open source project we announced, we just kicked this off last week at the Swamp Up conference, is called PYRSIA. And this is a collaborative effort with a bunch of different companies in the industry to build a system which solves a bunch of these class of software supply chain vulnerabilities by design. The name PYRSIA comes from the Greek reference to a communication system which they used to communicate over long distances using torches. So they'd put 2 rows of 5 torches on a mountaintop, and then they'd map those set of five torches into a grid to communicate the Greek alphabet, so you get up to 25 letters. I guess they only had 24 Greek letters. And this is how they would communicate over long distances. And we think in the same way, we can communicate software supply chain and create a more reliable system for doing this using open source technology. So the goal of PYRSIA is to be a reliable network, to be secure by design. So when you're pulling dependencies from it, you don't have to worry about namespace attacks. You don't have to worry about malicious code or like tampered binaries. And also that it's entirely open, so that you have both your repository software is written in open source, and it's a decentralized network which is not controlled by a single company. It's over an entire set of companies which collaborate with this. So the first part of this is the binary distribution network. We just released a system which allows you to do peer-to-peer downloads of container images for Docker. We're using the official Docker images. They're one of our partners on the project. And as a developer, you can download from other nodes of the network. You can download from other nodes running the PYRSIA system, or we're running trusted package repositories, which act as the source of trust in the network, and these provide the images which are available, and then also the immutable ledger so that you can get information about the entire history of what's transacted on the network. So as a developer, you can get your binaries more reliably because you don't have a single point of failure. You can get it from multiple sources, so you can be getting it from local sources, which will be faster than pulling it from places on the internet, or if you don't have great connectivity, you can also get it from local sources. And it gives you the kind of that verification and trust that you need to know exactly where your binaries are coming from. Phase 2 of the project, which we're working on now, is multi-node verification of build. So the idea is that rather than relying on a single source to build all of your binaries, you have multiple servers building in parallel. You're comparing the hashes of those, in the case of reproducible builds, to verify that it's exactly the same output file. And then only the binaries which pass verification are available from the network. So this, for example, would prevent the sort of attack which happened with SolarWinds, where a particular CI/CD got hacked. You would have to hack multiple companies' CI/CD servers, which are building the binaries simultaneously to actually attack the network. And For the consensus algorithm on this, we're, of course, using blockchain technology. Not cryptocurrency blockchain, but this is just blockchain as a immutable distributed ledger. And the specific consensus algorithm we're using is called Aleph BFT, Byzantium fault tolerance. So there's a great research paper written in 2019 about how the technology works. But I think one of the unique things about it is it's an asynchronous protocol, so it's quite fast as compared to some of the older consensus algorithms. If you ever used Bitcoin, you know that it takes several minutes for transactions to clear fully, because of the number of nodes and the synchronous nature of how it does transactions on blockchain. In this case, we're using a DAG, a directed acyclical graph, and post-verifying using the Aleph's algorithms for what the next block is in the chain. So this both makes the network faster, but it also makes it resilient to outages as well. So up to a third of the nodes of the network can be compromised, and you still get the same performance. It'll still have the same throughput of transactions. Up to 2/3 of the nodes can be compromised. You have to compromise more than 2/3 of the networks in the node to actually get any data corruption. So for you to effectively attack the network, you have to take over the majority of the nodes in the network, which I think gives a really strong guarantee that the network is secure, that it's high performance, it doesn't get impacted, and that it can be a stable and reliable way for you to depend upon your upstream open source libraries. The PYRSIA project's being done in collaboration with a bunch of different companies. So Docker and Deploy Hub's an OpenSSF member company, have both been helping us out with the work on this. So we've been working on this for about the past 9 months or so. Also, Huawei, FutureWay, and Oracle just joined the project as well, and they're also contributing things specifically for Oracle. It's more about securing Java libraries and focusing on the Java space. FutureWay and Huawei have some very interesting technology for doing secure Docker containers, where you can isolate the Docker runtime entirely from the host machine, so that gets rid of one potential attack vulnerability where the host machine could affect what's being built. So I think that these are both great contributions to the project and should help us a lot as we're moving into the second phase to do the build from source and verifying of images across the network. Okay, so this is already happening. The hackers are out there. They're targeting us as developers. I think this is one of the big changes we've seen in the past year, is it's gone from attackers attacking corporate networks, attacking enterprise software, to they're using us as developers for the vehicle to get inside. We need your help to make this possible. So we need everybody's help in the open source ecosystem to solve this problem. It's bigger than just any individual or any company. And I need all of your help. So I think a lot of folks know this, but I historically ran the Java community keynote at Java 1. And we had a lot of great, this was our Matrix keynote. We had a lot of really great presentations and keynotes where we'd have all the community members on stage. Anyone know this guy? No. So when I gave this presentation at the DevNexus conference, thank you, man.
Thanks, man.
What we did is we brought the whole DevNexus audience on stage and took a photo. Now, I think we can do better. What do you think? Can we outdo these guys? All right, so we need everybody's help. Let's get the whole audience up on stage for a photo, and let's help secure the open source supply chain. So help us secure the supply chain. Come up.
Come on, people.
And direct people to go to the left. Yeah.
Go to the bottom. Então, Sérgio, como é que estás? Para ali. Careful with the hole.
Okay. Welcome.
I already asked for that.
So we already checked with the venue. We're sure that the stage can handle the weight capacity of the attendees.
If not, please tell us no.
I like the sign. The sign's really nice this year.
Oh, it's the same one.
Is this the classic sign that you guys always had?
Yeah. Please careful with the sign. It's really fragile. No, it's the same. It was the one that we have on the church.
Nice.
When you came. See, this is the auditorium.
Yeah.
We wouldn't use it. We didn't use it when you were here the first time.
Yeah, I thought this was the same venue, so we just didn't use this.
No, it is the same venue, but Como é que estás?
Why?
Okay, no. I think we're running out of space.
Oh, bro. We can sit on the edge here.
Possivelmente. This was the gentleman. I mean, he only told me about this yesterday. We only have 4 minutes.
Yeah.
5 minutes. 4 minutes.
Okay. So I think we're getting close to capacity on stage. What I'm going to recommend is If you want to hop on the edge here, if you're in front,
make
you can
that.
just sit here. Yeah, just sit in the front here.
I
And then you'll get in the photo.
Yeah, I think
Yeah,
we
I
need to
think
know
we'll
align
be
people
good.
over here. That's okay.
All right, so we have our photographer in the center.
Just
Anyone
full-
else wants to squeeze in, just
Yeah,
stand
go-
in the front row.
Go in the front row now.
Yeah, just hop in the front row. All right, Roberto, come here.
Yeah, I'm going.
All right. So, we got everybody in the photo who wants to be in? Almost there. Yeah, just squeeze across the front row. All right, so here's being back from COVID. JNation 2022 is leading the charge. Thank you, Roberto. Thanks for the Hall team, which put this event together. This is an amazing
Thank you, man.
community event,
It wouldn't be possible without you.
and I'm just glad to be here with
we're
all
glad.
of my friends here.
Yeah,
I have
we're
a
glad.
lot of friends.
So Philippe is our photographer. He'll take a picture for us. Say hi to him.
All right, and raise your hands. Thumbs up. All right, and
Okay.
everybody, have a great conference.
Thank you.